address. So let's kick off with the recap of the last DRB, which concerned the integration to Corda. How do we integrate SGX with Corda? And we came up with sort of two dimensions to the integration points. One is sort of what we store in the ledger, and the second is where we store it. The x-axis on this diagram is the what. So in the privacy model, we would store the full transaction chain encrypted with SGX, and the integrity model, we would store only signatures over transactions. And the reason they're called privacy versus integrity is because from the very get-go, we planned with an SGX break, and there are various ways to break SGX, from like side channels to physical attacks, but we need to prepare for the eventuality that it will happen. And then the question is, what will happen if that occurs? And in the privacy model, we would lose privacy only because transactions would be revealed to the attacker, but we wouldn't lose the sort of integrity of the ledger, because you would still need to provision the full backchain between nodes. So you would need to provision it to a non-malicious node who will hack the chain again, and thereby ensuring that the integrity stays the same. Whereas in the integrity model, we only have signatures over transactions. So if somebody hacks an SGX Enclave, they can forge a signature over an invalid transaction, thereby gaining write access to the ledger. So an obvious way to circumvent that would be to require several signatures, like a special K out of N signature scheme. But that's not getting to that. And the other axis is the where, sort of where do we store transactions, where do we store signatures? So in the non-notary provisioning model, which is it's the top one, we would do the same thing we do currently, which is all participating nodes store the whole ledger or signatures. But with SGX, we have the possibility of offloading the responsibility of storage to notary nodes, or some kind of to the notary infrastructure. All we need to do is, all the node or the regular node needs to do is or go through the attestation process with the notary infrastructure, and then offload the transactions, and the notary infrastructure will take care of everything, including validation. So those are the kind of the two axes we have, and currently the current Corda model is the top left one. So if we just disregard SGX, Corda is the top left one. Yes. So the conclusion of the DRB was that we kind of need, well, we will eventually have all of these, and really the question is, what's the sequencing? How do we get there? Because each of these integrations have pros and cons, and it really depends on the business use case, which one we want to go for. Right. So this is just a quick example of the privacy model. This is a very, very dumbed down version of what's going to happen. So it's by no means complete. And the example basically is this. Can everyone see this? So in the example, we have two transactions, yep. T1 and T2, and T2 depends on T1, and the transaction that's being negotiated between these two nodes, node A and node B, is T2. So they're negotiating it, and node B in this example proposes it to node A, and node A in return wants to make sure that the input states of these proposed transactions are in fact valid, but there's no way it shouldn't see T1, which is a dependency. So how does it do it? It consults, node A consults its own enclave, which in turn recognizes that it doesn't have T1 as an example. So it requests provisioning of the transaction from node B's enclave. So they do a sort of dual attestation process where node A's enclave ensures that node B's enclave is in fact an enclave, and vice versa. And then node B proceeds to provision T1 to the enclave. And then node A's enclave can then verify T1, and if it finds it valid, then it can go through what's called a sealing process, which is an encryption process where you derive a key from the CPU, and you can encrypt T1 with the sealing key, and it stores it somewhere in a block storage or something, and then it can proceed to validate T2. And at any point in time, any of these steps can fail, and then we just return to node A an opaque answer of whether T2 was valid or not. And at no point does node A see in the clear T1. So that's the basic idea of the privacy model, where we provision all transactions back and forth. Right. So let's move on to the infrastructure design. So the basic idea is to provide a highly available cluster of enclave hosts. So we would have a sort of homogeneous services which you spin up, and then these hosts can serve enclaves on demand. So this is very similar to serverless architectures, so things like AWS Lambda, where we have these lambdas which are some code images, and the lambdas don't really know anything about the infrastructure underlying them. You just kind of push a lambda to the infrastructure, and it will take care of it. So the same idea applies here, except here we have enclaves, and the enclaves will be agnostic with regards to the hosting infrastructure, and the hosting infrastructure will be agnostic with respect to the enclave business logic. And so to do this, we introduced the notion of an enclave channel, which sort of abstracts a communication channel to an enclave. And this is sort of an opaque reference that doesn't actually pin the measurement, so the hash of the image. It pins the communication channel rather. So this allows us to upgrade enclaves more dynamically. This allows us to have more relaxed version of trust. So we don't need to. So if you do everything naively, during remote attestation, a client who's challenging the enclave would have to check a very specific hash of the enclave image, whether to ensure that it's running, the remote side is running the enclave that it's supposed to. But this is very inflexible. So instead, we can do whitelisting of enclave images, and then we can sign over these hashes. So for example, R3 can be a whitelisting entity here, but we can also introduce other control points like an auditing entity or other things. Okay.
Can I check it periodically? I'll just interrupt and see if there are any questions from anybody who's calling in. So if you do have a question, please shout out, or you can use the chat on the GoToMeeting to ask questions.
So any questions? So another thing that this allows. Yeah.
Sorry, I was a bit slow. So you mentioned R3 would be, I'm not sure if you said the or a whitelisting service. What is the flexibility you're foreseeing in that? Could that be a regulator or a network operator or any participant in the network, or what are the constraints that you have in mind, or that are hard fixed already?
the whitelisting public key will be burned into the enclave. So when you do enclave to enclave attestation, the enclave needs to know what to check for. So we need to burn that in. So it needs to be a sort of network-wide entity. So R3 would be one of these, or an auditor might be one of these. We were also thinking that, so if, for example, R3 would be the whitelisting entity, then R3 could whitelist malicious enclaves. And in order to mitigate this, we can introduce a party that the only responsibility of this party is to reveal measurements to the public and then sign over. So this way, even if R3 tries to introduce a backdoor into the ledger, the backdoor will be public. So we're not going to do that. So we can introduce, but sort of these whitelisting keys would be network-wide whitelisting keys. So another thing we can do with this, these channels is horizontal scaling on demand. So because we don't pin the specific measurements, we can do upgrades and also spin up. So let's say that the enclave requests another enclave to do some kind of function, for example, encryption of the ledger. This is a control point where we can spin up hosts on demand or spin up enclaves on demand. And it's the same idea as with the AWS Lambdas. Okay. Right. So, so this is an example deployment of how things would fit together. So we have a couple of components. So this is an example of a deployment where the user nodes have ownership over as much of the infrastructure as possible. But this is flexible, so we can also change this later. So in this example, we have bank A and bank B, and they both run some Corda nodes, and they communicate through flows as usual. The extra things we have is this key value source / discovery service, which allows the Corda nodes to discover specific enclave images and the specific enclave host to connect to. And we have the enclave hosts themselves that can load enclave images on demand. And there's the obvious sort of discover and connect step. This is also where we can introduce sort of client-side load balancing. So in this example, the Corda nodes use the enclaves to do verification. And there's another arrow here which goes back to the key value store, which is the updating of the state. This is required if we have stateful enclaves. So if we have enclaves that do encryption of the ledger, for example, then we need to update state in the key value store to indicate whether a certain CPU has been provisioned with a symmetric encryption key or not. So we need to track that in a piece of metadata to guide the routing verification. But I can go into this a bit detailed, I think. So let's not get into that. So in this example, R3 would own the enclave image store, which is responsible for this is just a static enclave image server with R3 signatures over the enclave. And we would also host the IES proxy, the Intel attestation service proxy, which proxies through to the Intel attestation service that is hosted by Intel. And the reason we need this proxy is because Intel requires us to do, well, it requires anyone who's using SGX to do mutual TLS with them. And so there's another whitelisting process here where they whitelisted one of our keys, and we can do this mutual TLS with them. Yes, this is an example setup. So the major components are this key value store / discovery, where we can control enclave deployment and sort of routing and the Enclave hosts themselves, which can load enclaves on demand and serve these enclaves. So let's move on to the roadmap.
Sorry, again, any questions?
Yeah, if there are any questions, then
on the deployment,
feel free.
Just a question about the IaaS proxy real quick. Is there an opportunity to package that as a service? So for instance, within Azure, you could envision like an individual organization wanting to spin up their own IaaS proxy as a service within their own tenant. Is that feasible?
Yes. So as long as the TLS key is whitelisted by Intel, anyone can use or maintain a proxy like this. So this is not a trusted part of there's no sensitive information flowing through the proxy. Only quotes, attestation quotes.
I'll also say here that we've been talking to Intel about this mutual TLS requirement, and I can't quite remember. We're under NDA with them because their product plans their own business. But let's say that there are reasons they have this, and they don't actually apply to every use case. So we're working with them to see if we can eliminate it for the sort of things we're doing.
Yeah.
And I think Dan from Intel's on as well. So I guess we can get any help from him we need if there's any specific questions, I guess.
Oh, yeah.
Yep.
Okay. Hi, Dan.
Hey.
Okay. So if there are no more questions, then let's move on to the roadmap. Cool.
Actually, I'm slowing down, sorry. So I see verification is external now to an external host. Is that a general capability that I haven't seen yet, or is that something specific to SGX, to this SGX roadmap?
So what was the question again?
So the node does verify, but it doesn't verify in an external host, the Enclave host.
Yeah.
Is that a new capability specific to SGX, or is that something general that I just haven't seen yet?
So we've actually had a project which puts verification outside of the nodes. And I think it was available for some time, but then we removed it because nobody was using it and it was extra code. But yeah, so we would move verification outside of the nodes as part of this.
So just a quick question. Can you hear me, by the way? Great.
Yes.
So the corner nodes there inside Bank A and Bank B, those are still effectively kind of discoverable or bindable notaries, which are then deferring the verify function to the enclaves. Is that correct? Because the enclave isn't running the notary itself. If I'm just trying to.
The hosts are, so these enclave hosts are actually completely separate from Corda. There's no Corda specific code in them.
Yeah. So the AMQP protocol, for example, is only being hosted by Corda nodes, and the enclave that's using a different protocol to transfer the request to the enclave host. Am I correct?
Yes. So that's we haven't decided on the specific protocol yet.
Okay.
But one of the things we're considering is gRPC.
Yeah.
So that would be a sort of standardized way of doing it. So, but there's another point here, which is, so how does the Bank A's enclave communicate with Bank B's enclave? So we would basically tunnel through the channel through flows and bridges to the other Corda node. So that's how we would establish a channel between banks.
Just to clarify one point, I first mentioned the word notary, then I think, just to make sure for the benefit of everyone else on the phone, this is, or unless I've misunderstood, you're just showing communication between two Corda nodes. There's no,
this is not a notary.
Yeah.
No. Yeah. But one
Okay,
can be a notary.
Understand. Okay. Thank you.
Okay. Any other questions?
So going back to the penultimate statement, if you were to go back to the flow that you showed in your earlier diagram, the part where you were doing it, and there we go. So when we're trying to do an attestation from node A to node B for transaction 1, where it says a test and there's a retrieval, that's actually a flow, in fact, is it, between the two nodes, or is it some mechanism by which, yeah, that must be the way it's working, right? So from, forgive me,
yeah, so there would be a flow that forwards encrypted packets back and forth.
The intention here is that it's effectively an upgraded version of the resolved transactions flow that Corda already uses, right? So the nodes of handshake and the details of the attestation would be hidden from the developer within the flows.
Okay, cool. Thanks.
Okay, so the roadmap kind of split it up into 4 chunks of work. In the first, well, so that's kind of the question of the CRB. How do we sequence the sort of major chunks of work? So the first chunk is going to be stateless static enclaves. And what this means is we would use enclaves as just a way to prove some kind of computation has happened, rather than using it to actually do sealing or encryption, because that requires much more infrastructure. And the static part means that we would link the JVM bytecode into the enclaves as the first part, because actually let's move on to this would be the first chunk of work. It's just a rough breakdown of what needs to be done. So at the end of this first chunk, we would have basically a service that abstracts away a cluster of enclave hosts. You can connect to it, and it serves a specific image or a specific piece of functionality, and then you can do signatures and prove that this piece of functionality has been run on the enclave, but it's not going to do encryption, as in long-term encryption, sealing.
There are probably loads of dumb questions in this presentation, and I'm going to ask one of them. But when we say static, is that a reference to tying an image to a particular Corda application? No, it's not that.
Yes, that is that. So, yeah. So after this, we can start integrating with Corda, but it would be quite difficult because we would have to link a specific Corda into the enclave image, and then sign it with our trace. Right. HSM, and then use it. And then so if anybody wants to update or change it, we have to do it again. Right. So
that's a question, right? So you assume this is the first stage.
Yeah.
Yeah. So that's a cross-check, really. Why is this the first stage? I think. So
right. So why is this the first stage? The reason is that stateful enclaves are much harder to deal with because data at rest raises a lot of questions around how do we guard the data, and how do we ensure that the security guarantees don't degrade over time, or if they degrade, we need to have control over how it degrades. And this raises a lot of questions. For example, how do we need to start doing certificate expiration checks, because we don't want enclaves to provision to other enclaves who have expired or who are whited by a key that has an expired certificate. But we don't have a notion of time inside enclaves. So how do we deal with that? And there are some plans on how we're going to do this. It's just there's a lot of infrastructure we need to set up just for this. We also need to set up things like encrypted block storage, which we might want to do ORAM block storage, so that you cannot infer things about the ledger based on the access patterns. There's just a lot of infrastructure that we need to do stateful enclave. We also need to yeah.
One option you could do to kind of accelerate that is, within Azure Key Vault, you have the storage that can be tied to the encrypted block storage as well. So I think you could do a reference implementation with Key Vault rather quickly to at least kind of prototype and do some rapid learning to figure out what you want the larger roadmap to look like.
So sorry, I didn't get much of that.
Use Azure Key Vault to prototype some of this. Maybe I don't know, Mike, did you get that or need to expand on
Yes,
the
yes, I heard. The speaker, I'm afraid I didn't get his name, was saying that Azure Key Vault supports integration with an encrypted blob store. And the Azure infrastructure has this sort of notion of an encrypted key value store already. So that might be a good environment to do rapid prototyping and rapid learning.
Yes, exactly. And this is Michael Glaris from Microsoft, by the way.
Hi.
Yeah, so...
Sorry, Andres. It's not really a question, but and if it's late on in the presentation, then I'll just tell me to shut up. I was wondering if you could speak about which bits of this have been implemented already.
Oh, so we have, so in terms of POC, we have the IS proxy, we have a Diffie-Hellman. It's not Sigma I, but it is a Diffie-Hellman. We do have an AVN, an embedded AVN. That's kind of what we have from this.
Yeah, AVN is a JVM.
Yes, it's a JVM. We also, so this would be the next proposed step. We also started working on embedding hotspot, and we might experiment with substrate VM, which is a crawl JVM. But substrate VM doesn't have some capabilities that we need, like dynamic bytecode loading yet. So we need to fund it up a little bit. So, but this would be the next step. This is dynamic stateless enclaves. So this means that we would be able to load bytecode onto the enclave dynamically. And obviously this requires some care, like we need to do proper sandboxing. We need to do bytecode verification. But once we have this, we have sort of a true integration point to Corda, which is we can load contract onto the enclave dynamically, and we can do verification. And this allows two sort of integration points. One is the integrity model that I mentioned earlier, where we provide signatures and then we trust SGX signatures as a proof of validity. And the other integration point we have is similar to that. So we get signatures of validity, but we still do the provisioning, the full provisioning between nodes in the clear. It's just that we also forward the SGX signatures to the notary, which is a non-validating notary. It will not run validation checks in and of itself, but it will check the SGX signature. So it's a sort of semi-validating notary. That's why it's called semi-validating.
The two slides, this one, the dynamic stateless and the static stateless, is there a dependency to finish the work on one? Obviously not, because you said you've already started work on the dynamic one as well. But yeah. What is the dependency, if any, between them?
There is a dependency between them in general, but the JVM embedding work is kind of separate to that. So that's why we started working on that.
Right.
Also because it's a big chunk of work and it's a big question mark work because it's not easy to do.
At this point, you've made the assumption this is the second step.
Yeah. So this is the proposed roadmap. So I think that this should be the next step, but we can also go along the stateful path of development, in which case we would need to basically solve the stateful routing problem. Like, for example, if we have enclaves that do encryption, redundant encryption of the ledger, we would need to make sure that we route to the enclave that has the key provision. So we need to build that into the discovery process. So that's sort of this side of the tree, and the other side of the tree is solving the certificate expiration / time problem, which is a big question mark for me.
Can I ask a question? Is it possible that we share the secret storage so everyone has the same key, or somehow all of the keys from each enclave can decrypt the data? So you're not.
We have one shared key across the network.
Okay.
We could do that actually, but I'm not sure if that's.
So you're not. You don't need a discovery service then, because every enclave can.
Oh, we would still need a discovery service, because if you spin up host on a new CPU, that host still doesn't have the key provision. So you need to make sure that it gets provisioned, and
but only for the contact.
Yes. Yes. So yeah. So once we have that abstraction, the enclave is sort of homogeneous in this regard.
But maybe I missed the same, but you're assuming in that case, the only thing you're relying on, like, physical protection of the machines to avoid an adversary getting access to data. Actually, that would the physical access to the storage machines.
Yes.
Yeah.
Well, the key wouldn't be revealed at all.
But if maybe I'm misunderstanding what Costa's saying, but if every node, if every enclave in the network has the same key, then that would mean data I've encrypted, because it's private to me, will be accessible to you if you had access to my blob store.
Yes.
So
but I would still need to somehow get hold of the key, which I cannot do because it's stored within the enclave. So it basically means if we share the key, it means if any but one participant breaks SGX, they have access to all the
sharing is logically restricted to within enclave.
Okay, because you've got the extra level protection, which is the code in the enclave should only do the right thing in any case.
So that key would only provision between the specific enclaves that do the encryption. Yeah, I also put a little box here, sealing epochs, which so it's a very vague idea about how we can do this, how we can enforce upgrades over time in the ledger. So how we can keep upgrading algorithms, keep upgrading enclaves, and basically make sure that if SGX or some older enclave gets broken, the attacker won't have access to the newer data that's encrypted with the newer algorithms or enclaves. So that's the.
Can you tie the whitelisting to like a compliance check? So, for instance, if you're on an older version, you fail the compliance check and you get removed from the whitelist.
I didn't hear that. Sorry.
Can you tie whitelist compliance check to a whitelist? So if you fail a compliance check, you get removed from the whitelist.
You mean the whitelisting of the enclaves, or?
Yes, for the version. Yes, for like the version that you're running. So if you're running an obsolete version of the whitelist of the enclave.
So this ties into sort of the expiration and general checking of whether what I'm talking to is a trusted as of now. But this is so a malicious host can just fake this, so it can provide the old whitelist of the enclave. So we can revoke it, but we need to then solve this problem somehow. For example, we can have a trusted oracle that does the certificate or the whitelisting checks. And if we have an oracle with it, it can also do the date time checks. So that's the thinking we have currently.
That's true, but I think the most common case for revocation, right, is where I'm thinking of sharing data with you or relying on an attestation of validity from you. And it's in my interest to not let you use the revoked enclave and that's what I'm checking through the remote attestation, right? So at that point, date is sort of irrelevant. If I have a list of Enclave images hashes which are trusted, then I don't really care what the current date is. I just know you're on the list or you're not.
So there's another question.
Yes, makes sense to me.
Okay.
There's another
question. Yes.
Are there memory limits for running the deterministic JVM on SGX? Do we need development tools to verify SGX compatibility? So SGX, okay, so in SGX 1, there is no limit in the sense that we can pre-specify the size of the SGX heap. So we can specify it as large as we can, or as we want. It's just that it's not going to fit into the Enclave page cache, which is limited. It will have to start doing swapping in and out of main memory, so that's going to be slow. In SGX 2, we can add Intel added instructions that allow you to add pages to the Enclave dynamically. So we don't need to pre-allocate heap for the Enclaves. So as long as we're using SGX 1, there is going to be a limit that we have to statically set, and then we need the tools to verify whether you fit into your Corda fits into this limit. But again, we can set it to as large as we want.
Is SGX 1 superseded already? In other words, by the time we deploy, will it be
I don't know about the release plans of SGX 2.
Okay. That's not it.
For our use case, we can pre-allocate anyway because the deterministic JVM will be imposing resource limits on the code, right? So resource limits are effectively a network parameter.
Oh yeah, that's another thing. Yes.
Which comes to the second question, I guess, which is, if I've understood your question, Fuzz, it's if someone's writing a Corda app, how do they know the app will work when SGX is turned on?
So that's a good one. There's another project that I didn't include here, which we're finishing now, which is a sort of preview of the deterministic sandbox part of this whole infrastructure. So we would like to roll that out at some point, so that you can check whether your Corda app actually works against the deterministic sandbox. And the sandbox also does, as Mike mentioned, some resource counting. So that includes CPU and memory usage.
You mentioned earlier the idea of an Enclave cluster.
Yeah.
Does stateful aspect of stateful Enclave, is that much harder to achieve when we need to cluster them?
So that's one of the reasons that we have the concept of a channel. So on a first look, it is hard to achieve, but we can make, so the reason it's harder to achieve is because there's the statefulness, so you need to, how do you scale that up? But we can do a little trick where, so for example, let's take the stateful example of encryption, like redundant encryption basically. We have a shared key that's shared between enclaves, and we want to make sure that if you spin up a new host, it will be provisioned at some point. So what happens if you route the request to this new spun up host on a new CPU that doesn't have the key provisioned yet? Well, it can lazily request the key in the background from other enclaves, and then it will be provisioned, and then you can just keep going as if it always had the key. So we can propagate the state in the background without disrupting functionality, so we can scale in that regard.
Andres, do you have a slide 12, or is this the end of the presentation?
So there's another slide about data at rest. So this is the sort of supporting infrastructure we need to actually do the storage. So this is where we mentioned redundant encryption. This is just what I talked about. We need to, for this, we need to implement channel tunneling. So we need to be able to route enclave to enclave traffic through the bridges. And we need to implement the actual storage of the blobs somehow. And I also put in the ORAM storage. There are some papers which are about how to do ORAM storage using SGX. So that you cannot even infer anything about the access from the access patterns.
Can I ask you a question? When we're talking about encrypted storage, are we only interested on perfect matching on queries? Because to have an encrypted searchable storage is by far more difficult.
Right. So we generally only need key value lookups. Okay. So we have transaction hashes, and we want to look up the transaction body.
Okay. So this cannot be used for the vault. For example, if you want to have more, I don't know, bigger than something or smaller than something.
But that's a good point.
The vault doesn't need
the vault doesn't need, yeah.
Okay.
So the vault only requires transaction in the clear. So that transaction that you do have access to. Okay.
A couple of questions, and one from Sean. Will each Corda app have its own enclave?
That ties into the question of whether we're going to start integrating with the static enclaves or with the dynamic enclaves. So in the case of the dynamic enclaves, we can load bytecode dynamically. So we don't need to specialize an enclave image for each Corda. If we do integration here, then we do need to do that.
And then two other quick questions. Okay, well, actually, Mike's already answered JC's. Yeah, we know this has gone deliberately very deep. So for those of you who aren't, so JC's question was, I need a 101 on this. Who can bring me up to speed? And we'll handle that. We know this has gone very deep. That was deliberate. We thought we'd just drop you straight into the deep end because this is a design review with that's in progress. But there's also a question from Kishore. My understanding is Docker and most virtualization environments do not support SGX yet. Are there any plans for virtualization support or something else that would enable faster setup or learning for people doing a quick on-prem setup?
There might be Docker support. I haven't tried it myself, but because Docker isn't kind of inserting a hypervisor in between the OS and the hardware, it's a little bit easier to work with. So there might be Docker support there, but again, I haven't tried that myself. And then I believe that hypervisor support is on the SGX roadmap. I don't recall at what point that lands though.
All right, thanks, Dan.
Yeah, I mean, the SGX drivers and things do support virtualization. That is there, and we've seen people do it, provide support for that, do some experiments.
Also, we've used Docker with SGX before. All you need to do is forward the device, the driver device through the container.
Yeah, so it works. There was so on the question on will each Corda app have its own enclave, this actually rolls into a question I had, which is what I'm looking for here, and what I'm thinking about is ways in which we can break down this first step even further. So there's things like provable computation as a service and things here, where I'm thinking, can we start with something where it's like, okay, if you run your Corda node on a host that has SGX, you can start to benefit, or do we, can we ship the JVM as an independent component as a static stateless enclave where you link code in and start to use it earlier for use cases like aggregation of statistics, right? There was a question on the Corda dev mailing list about that, and we've talked about it a lot. Basically, this sort of first static stateless enclave thing, does it need to run on Kubernetes, for example, or can we deliver an artifact earlier that, and then add Kubernetes support in a second version or something like that? Basically, can we launch and iterate and break down some of these sub-steps further so we can do more launches and more iteration?
So one of the difficulties with launching the static enclaves is we need a signature over the enclave image that's whitelisted by Intel.
Yes.
So
yeah, I mean, we can imagine, for example, in the early days, there will be, a limited universe of apps, and some app developers are working closely with us. So could we just load up the top 10 smart contracts that people want to use, or spin 5 enclave images and whitelist all of them, for example, to get something up and running before the full-blown, scalable to 1 million apps that we've never seen before version is implemented?
Yeah, we can do that.
I agree.
This is Clay. Quick question. One thing that I haven't seen that I'm curious about, is there any work or thought given to mixed networks where some nodes are using enclaves and using SGX and some nodes are not, their traditional Corda networks?
Yes, it's not easy. So first, we could do something like the enclave, the nodes that don't have access to SGX, they just kind of check the SGX signatures and trust it. But the problem is, what happens if we have a node that does have SGX, it sends us or negotiates a transaction with a node that doesn't have SGX, which accepts it, and then it tries to connect to or progress the ledger with a node that again has SGX. This new node won't be able to request provisioning of the old transactions because there's no enclave to connect to. So we would need to solve that problem somehow. For example, by like saying, oh, if you want to resolve the rest of the chain, or connect to this guy who does have SGX. We could do something like that. But
is it possible that you have the encrypted?
Sorry, I thought that was the point of your RPC call and your verify, and having that whole discovery list of enclaves. You can dynamically load them in that serverless infrastructure pattern.
So the discovery is within one node. It's not done through nodes.
We're not talking about sort of serving enclaves as a service remotely, or to.
This initiative does allow that, but I didn't discuss that.
Yeah, so all that discovery was within one organization, which is SGX.
Yeah, there's two cases. There's one where you don't want to use SGX, and you've just made that decision, and that's what Andras discussed first, where you'd have to basically outsource the resolution and so on to a node that did, and then you use the remote attestation to check they did it correctly. And there's the second one where you're happy to use it, you just don't have hardware on hand, and you're happy to run the verification on outsourced hardware, and that's when the protocol between the node and the verification enclaves comes into play.
Yeah. Also, so this is also where the notary provisioning might be relevant. So if we say that the notary nodes are all SGX capable, then you're not required to run SGX. You just provision to the notary's SGX enclaves.
Hi, this is JC. I have a quick question here. What is your vision? Do you envision networks to be entirely SGX compliant, or do you want hybrid networks? What would you like to achieve?
I'm not. I don't know how to answer that question. In my opinion, it would be easiest to have to start separate ledgers that run on SGX, and then later on think about like how we can mix SGX and non-SGX nodes, because that requires extra work.
Yeah, I think go ahead, James.
One thing that I want to mention. One thing I want to mention is that sort of upgrading to SGX. So if if there's no sort of going back, we can't do that. So if there's existing ledger data that wasn't encrypted, we can sort of upgrade that to SGX. It's just that it's hard to go back.
Yeah, I'd say this sort of incremental deployment is probably something we're going to do, or have to do in order to launch this, because even if we sort of do this incremental launching where the first version is, has a few smart contracts that are popular baked in or something like that, and then we upgrade to dynamic loading, there will be points where not everyone is using this for various reasons. So this question of mixed networks will come up as part of deployment, and the vision certainly includes a sort of incremental deployment, because we can't break backwards compatibility once, as now things are starting up, right? So there will be measures in place to support that kind of sort of mixed mode, at least maybe on the per app level or something. Long term, the vision is, it would be nice if everyone were to be using this technique, because then we could say the Corda ledger is encrypted. Boom. Right? Nice and simple. Everyone understands that. In the very longer term, there may be a migration to zero knowledge proofs and things on the card as well.
So that was more or less what I was going to say, Mike. I have a question though. Do you have a decision for the design board?
So the question is, the big question I want to answer is the high-level roadmap of sort of where do we start integrating with Corda? Should we start integrating once we have this sort of static stateless Enclave infrastructure in place, in which case we would need to have hard-coded Corda Enclave? Or should we do dynamic enclaves first, and then we can load the contracts on demand, or perhaps start doing the stateful stuff, which is the hardest part? That's the question I would pose.
Can I add, if we start with the static model, which is the easiest one, and we need to evolve some of the contracts, because initially we know there are about, I don't know, a few hundreds, or I don't know, just a few contracts that we want to have them on SGX. It is difficult to have another static step, so we upload some new contracts, and again we stay static, and at this time we have some time to create the dynamic thing. Is this, I don't know, is this very difficult to have it? I mean, the sooner the best, or we should go dynamically at day first, because you feel in the next, I don't know, 6 or 9 months this is feasible.
So as I mentioned, one of the difficulties is we need to loop in our HSM or some of the HSM to sign the Enclave images. But what we can do is Intel has simulation libraries where you're not going to use SGX hardware, but you can already test your Corda. So that would make this much easier. So we could go down that route.
I guess, question would be, right now we have, let's imagine, so we have, I mean, the attack's been formed of a large number of participants in the attack are people who are taking Corda applications live in the coming weeks, months, and months. Right now, they will be shipping Corda apps, the static Corda apps to the customers, and the upgrade process will be to install another jar file, and then go through either a contract upgrade process, explicit, or through implicit. I guess, if I'm understanding Kostas' question, if we were to say the way you upgrade a Corda app is through the explicit process, therefore through a contract upgrade transaction associated flow, if the infrastructure you have available is static stateless enclaves, how much how much effort is it? Does that fit in with it? So if we're already taking the pain of distributing updated jar files, is it just a case of distributing new enclaves and then executing a process to say, trust this one as well? Or,
so that new Corda app would also include the flows that do the SGX verification. So I think it would fit to the model, because we don't even need to change the contract itself. We just need need to change the flows to do this, do the contract.
From a sort of an engineering delivery point of view, I guess I'm strongly of the opinion that we should deliver early and get something in use and get feedback on it, because it'll guide our future. And you know, it's a large-scale effort just to get stateless static enclave available, I guess, still. But it gets, for example, people that are building applications thinking about the possibilities. And yeah, there is additional complexity, which is, of course, a cost. Complexity has a cost. But the sooner we get feedback on what that cost is, and the sooner we get people thinking about the opportunities and the business case, if you like, for having an encrypted ledger, the better. So it's not really a technical perspective. It's more of a business perspective to get that early feedback and reward the people that are working on it as well. That it's not 2 years, in a dark room, that you come up for air after a year. Yeah.
So, to answer your question, Andras, I think this roadmap is good. I think that sequencing makes a ton of sense to me. What I think we should do is make the first, so the first milestone to me seems like, ship, possibly Avian. I mean, I saw the Igor's hotspot embedding work is going pretty fast actually. So who knows? Maybe not Avian. Have that embedded as almost like a library that you can just access through JNI or something. And if you run it on hardware that supports SGX, then you can run Java code inside the enclave, do some computation, do you can get the messages needed to do remote attestation, and it's up to the user to move them around. And that's actually an interesting milestone and product all by itself, because then we can ship that and say, okay, for those of you who want to do anonymous aggregation of statistics, which is a use case that does come up again and again, then they can say, we can give intrepid developers this SDK and say, okay, you've got the tools, you do it over HTTP or whatever, do it however you like, but get some feedback from that JVM and SGX, because we've got most of that already. Next step after that, same thing, but with the integrated with the deterministic JVM. And then, now contract developers can use it. We've run contract code inside a SGX Enclave like a year ago. So, there's nothing wildly different there. It's just a packaging issue almost. And then from there, we can start to move up and, put in place of the repeat deterministic builds and, start to integrate with flows and things.
So how would you do the signing process?
Well, I would post to Corda dev and say, roll up. If you've got an application, or we'd talk to the people we're currently working with, the partners and so on, and say, okay, if you have a use case, let's say a statistical aggregation use case, write some Java code to implement it, and we will we'll check it and sign it, right? And we will effectively assert it is not malware, and give you back a signed enclave. Or potentially if that go back to Intel and say, or tell them to go to Intel and say, well, this is a Intel Go whitelist. We'll work something out that's reasonable, but we do it by hand to start with, right? And then keep it somewhat limited so that we get enough feedback and people can start to experiment. We're not swamped, and then build it up from there, making it scaled to more apps, more users, more hardware, horizontally scale, more traffic, and so on. But the key is to start with something that doesn't scale and scale up.